Welcome back. Here we start the second section of the Maths Lite program. It focuses on Type 2 maths, which causes most of the difficulty students encounter in their school maths courses. Normal language is used for communication in maths. The subject supplies a few extra words. The main difference between maths and other subjects is in maths a lot of that is written. If we wrote every word fully, most of our time would be consumed simply doing that. So in our written communication, most of the words are abbreviated to one letter or one symbol. When we abbreviate a statement, so that it's quicker to write, we call it an equation. In English, we have doubling John's age gives 30 years of age. In maths, it is 2j equals 30. Writing a number next to an abbreviation indicates multiplication. So this means 2 times whatever j represents. Notice that in maths, the use of a symbol j represents what we are interested in here. Use of the equal sign makes it a statement of fact. Do not bother to include the units years. We could have written this equation as 2x equals 30, where x represents John's age in years. Or we could have had 2 question mark equals 30, which means 2 times whatever the question mark represents is 30. No matter how we write the equation, the missing part is 15. Processing the information in an unfocused mathematical statement, such as 2j equals 30, to the stage where we clearly know the value of the missing information, j is 15, is called solving an equation. We have a very simple method of processing an equation to find the missing value it holds. It is shift the numbers away from the symbol. The solution to the equation 2x equals 20 is 10. It is obvious, many students say, but we do not know that the relevant number is 10 until after we have processed the information. We are more aware of the processing when it requires more effort. The solution to the equation 2x equals 1.9 is 0.95. People are more aware that they are calculating with that example than with the previous one. Our processing, solving the equations, involves undoing the changes the equation describes. This reverses the functions or processes mentioned in the original equation. Where we are told 2x equals 20, we know that x must be 20 divided by 2, which is 10. If we are told x plus 6 equals 16, then x equals 16 minus 6, which is 10. In each case, the original processing mentioned in the equation, 2 times x, becomes something divided by 2. or x plus 6 becomes something minus 6. Another possibility to consider, 2x plus 6 is 26. So x is 26 minus 6 and then divided by 2, which is 10 again. Notice that in the last example, we had to deal with the numbers 2 and 6 in a specific order. We shifted the 6 first, and then the 2. The 6 was further from the letter, or letter term, so it goes first. The thing shifted requires its own entry in the formal working in order to maximise accuracy. As a general rule when solving, brackets are used to keep things together, so what's outside the bracket is considered to be further away. 2 bracket x plus 6 equals 26. The 2 is outside the x plus 6 part. It is further away, so we shift the 2 first. Plus and minus signs keep things apart, and that can make things further away. In the equation, 2x plus 6 equals 26. The plus sign means the 6 is further away from the x than the 2. So shift the 6 first. All you have to remember is when you shift anything away from the letter in an equation, reverse the processing. Mathematically speaking, we are applying the inverse function. If the symbol in an equation has many numbers operating on it, the solution will involve shifting all of these numbers, one at a time, and in the correct order. Examples of that order follow. Remember, at all times, the number to be shifted is the one which is furthest from the letter or symbol. In each case, the blue number is furthest from the letter at that stage. The arrow indicates it is moving to the other side of the equal sign and reversing its process. So in example 1, 2x plus 1 equals 10. The bracket keeps the x and the 1 together, so the 2 is further away. So when we shift the 2 to the other side, its process changes from multiplication to division. So we have 10 divided by 2 is 5. Now the plus 1 has to be moved. When it moves to the other side, its process changes from addition to subtraction. So we have 5 minus 1 is 4. In example 2, here the 2 is further away from the x because of the plus sign. So when we shift it to the other side of the equal sign, it becomes subtraction. So 50 take away 2 is 48. Now we have to shift the 4. 48 divided by 4 is 12. Example 3. 0.5x minus 2 is 10. The subtraction keeps the 2 further away from the letter or unknown. So when we shift the 2, it adds 10 plus 2 is 12. Now we have to shift the 0.5. When it's written next to the letter, it indicates multiplication. So when we shift it, we will use division. 12 divided by 0.5 is 24. Example 4 has 3 numbers associated with the x. The 3 is furthest away, so when we shift it, it will multiply. Now the 2 is further away from the x than the 4 because of the plus keeping things separate. So when we move the 2 to the other side, it becomes subtract. 30 minus 2 is 28. Now there's only the 4 to shift. Multiplying becomes division. So 28 divided by 4 is 7. Example 4 began with 3 numbers on the side containing the letter. This resulted in the processing having 3 of the basic shifting step. The process is simple, but it can be repetitive. The numbers are moved away from the letter. It doesn't matter which side of the equal sign the letter is on. The numbers move, the letter stays where it is. So if we look back at example 4, 3 numbers to shift, 1, 2, 3. In each case, just a simple arithmetic calculation leading to an answer. Example 5 begins with the letter on the right-hand side. 50 equals 4x plus 2. Shifting the 2 means the addition becomes subtraction, resulting in 48 equals 4x. Now we shift the 4. Multiplication changes to division. 48 divided by 4 is 12. Now we have our solution. We have solved the equation. Notice that in each of the 5 examples, the letter never moves. And both it and the equal sign are kept one under the other in the working. As you can see, the equal signs and the letters. What changes is the presence and appearance of the numbers. Notice that in each of the 5 examples, the letter doesn't move. Both it and the equal sign are kept one under the other. That is all you have to remember and apply in each case. The functions used earlier are not the only ones you will encounter in a maths equation. There are many others. For example, if we're told that x squared is 36, then we know x is the square root of 36. So x is 6. Similarly, if we started with the square root of x is 6, our working is x equals 6 squared. When we shift the square root sign to the other side, the processing becomes the inverse. This leads to x is 36. The square root function is the opposite or inverse process of squaring. It undoes the changes caused by using the squaring process. So if we square 4, we get 16. If we then use the square root on the 16, we get back to the 4. They cancel each other out. It helps to know what the function means, but that's not critical when solving an equation. You simply need a way of reversing it, and most calculators have a button that does that. Calculators often use the symbol -1 to indicate the reverse function. Sine to the -1 means the inverse of sine. You don't have to know what the sine process is, but you can undo its processing by using a calculator. Mathematics sometimes gives the inverse process its own name. The logarithmic function undoes the changes brought about by using the exponential function. Logarithmic and exponential are inverses. One undoes the other. We have mentioned the exponential in a previous example, but we will look at both of these functions in more detail later in the course. Some calculators use the abbreviations log to indicate the logarithmic function as the inverse of exp, representing the exponential function. We've reviewed our work on equations. A lot of that was not new, but we have to consolidate everything as we move along so we can then build on it. I hope to see you in the next lesson. See you then.